Hello everyone. I am Nishkar and this is my I2 for the BVLSI class. Um I am demonstrating two circuits over here. So my first circuit is a positive edge triggered D-latch. As you can see, I have implemented the D-latch using transmission gates. So that's my approach. So over here, the working is very simple. So we have a clock and then we have two inputs. So whenever my clock is one, that means my clock edge is positive. That's when my circuit will uh, give me a change in value or it will take any input change. I'll go over it a bit more in depth when I show the circuit, but that's the general notion. Whenever my clock is one, I will have some change in the output, and whenever my clock is zero, I will have no changes in the output. That means my uh, D latch will retain information and it will hold the previous state. So if we go on and think about it, it's quite easy. So moving on the next slide, transmission gate. So a transmission gate is nothing but a PMOS and an NMOS together. So over here, we give our control input. So it can be anything. It can be A or B or clock, anything. So over here in our circuit, it's clock. So I have one clock and I have a clock bar. So for clock bar, we have a inverter circuit over here. So over here, as we can see, a transmission gate uses an NMOS and a PMOS transistor to pass signals efficiently without any degradation. Uh, and as we know that NMOS transistor conducts very good for logic 0 and PMOS for logic 1. So this ensures a full voltage swing. So we won't have as many transmission losses or any signal attenuation. So this is how a transmission gate looks. Talking about the circuit for my D-latch. Uh, this is the circuit implementation. So over here, we have our transmission gate. So we have given inputs Q bar and we have given inputs clock bar and clock over here. We have an inverter circuit for clock and clock bar. We have our input voltages for VDD for my inverter circuit, for D as well as for clock and clock bar. Then we have our two inverter circuits, which uh, inverts our value. So over here, we get Q bar, and then Q bar gets inverted again, and then the output we get Q. And as you can see, we have another transmission gate down under. So this makes a feedback loop to our input. So this is how we actually retain information. So as I talked about uh, in the earlier slide, where I said that whenever my clock is zero or I have no clock input, my entire D latch will retain QN information, or if I put it in better words, it will just retain the previous. So we can look at the output of the circuit to understand it better. So this is the output of the circuit. So over here, as you can see, this is a positive clock. On a positive clock or clock one, we have our D input, which is also positive, to which we have a positive Q out. Then when our clock goes from 1 to 0, I can point it out. So it's 1 over here and it's 0 over here. So when it goes from 1 to 0, our output still remains the same because it is positive edge trigger. That means whenever our output changes from 0 to 1, our output will change. Else, it will always retain the previous state. So over here, when our output went from 1 to 0, our VD was still positive. So our VQ was always positive. And since we have zero clock, that means our VQ signal will retain its previous state, which was 1. Hence, we have 1 over here. And as we can see, when our clock signal is 1, our VD goes from 1 to 0. Our VQ also drops from 1 to 0. But this only happens when our clock is 1. That means this is positive triggered. And as you can see, when our clock is 0, and then when our VD changes from 1 to 0, our Q still is on 1. So it retains whatever value of VD was on clock 1. So this is how it works, and this is how it goes up. And then we just have VQ bar, which is nothing but inverted VQ. So it will always be opposite of what VQ is. So that's pretty much it. And this explains the D-latch implementation using positive edge trigger or positive trigger. Thank you.